तो यहाँ पे कुछ एजम्पशन हम लोग करेंगे कि पार्टिकल एक दूसरे से अट्रैक्ट नहीं हो रहे हैं, रिपेल नहीं कर रहे हैं एक दूसरे को, ठीक है। Yeah, it's about mole concepts and stoichiometric, okay. And so they don't attract each other, and then the particle don't repel each other, okay. ये भी यहाँ पे assumption है कि the particles don't take up any space, okay. And particles कोई volume नहीं ले रहा, ठीक है। But in actually no gas is ideal, okay. रियल गैस बिहेवियर जो होता है वहां पे अट्रैक्शन होता ही होता है पार्टिकल्स में, ओके। बट यहाँ पे assumption है कि दे डोंट अट्रैक्ट ईच अदर, द पार्टिकल डोंट अट्रैक्ट ईच अदर and they take up no space, okay. So this is a assumption for ideal gas. So ये assumption मान के हम लोग इस लॉ ये लॉ को हम लोग स्टडी करेंगे, ठीक है। गैसेस का जो लॉज है, सो गैसेस के लॉज को हम लोग स्टडी करेंगे, ठीक है। सो इज इट क्लियर? यहाँ पे कुछ प्रॉब्लम, कोई कंफ्यूजन, एनी कंफ्यूजन है? लाइक दे डोंट, वी आर अज्यूमिंग फ्यू थिंग्स, ओके।
ओके सर। यस सर।
ओके, तो यहाँ पे ये दो assumption है, इसको should remember it. So now is to go for Boyle's law. Okay? So basically these are the variables. P is the pressure, okay. So P is the pressure, okay. Pressure. V is the volume, okay, and N is the mole, and T is the temperature. So now Boyle's law में what basically happen is pressure is inversely proportional to volume, okay. तो यहाँ पे जैसे जस्ट मान लो अगर यहाँ पे एक वॉल्यूम, एक बैलून है, ठीक है। अब इसमें यहाँ से प्रेशर एक्सर्ट कर रहे हो, यहाँ पे भी वॉल्यूम है V, pressure when you started exerting, so then it will compress, and when it will compress, then someone is trying to type something. Please don't type anything, okay. So when we start exerting pressure, the volume will start decreasing, okay, right. Balloon will compress and pressure when the so suppose it has compressed till here, so now it will be more, pressure will be more and volume will be less, right. So pressure is inversely proportional to volume. That's the Boyle's law. Boyle's law क्या कहता है कि प्रेशर जैसे जैसे प्रेशर इंक्रीज करोगे वॉल्यूम डिक्रीज करेगा, ओके। तो अब यहाँ पे क्या हुआ कि P is inversely proportional to volume, तो अब इसको अगर मुझे इक्वेट करना है तो एक कांस्टेंट यहाँ पे रखोगे और PV सेकेंड, तो यहाँ पे क्या हुआ कि PV is equal to K, तो यहाँ पे P1 V1 is equal to K, similarly P2 V2 is equal to K, okay. So then finally we can say that P1 V1 is equal to P2 V2. तो ये बॉयल्स लॉ होता है कि प्रेशर इज इनवर्सली प्रोपोर्शनल टू वॉल्यूम। तो और यहाँ पे assumption क्या है? टेम्परेचर इज अ कांस्टेंट एंड mole is mole. This N is basically mole. Do you know what is mole? No, right? So mole is basically weight upon weight of the any molecule upon molecular weight. Okay. So this is mole. We'll study in more detail in further slide. So basically, mole and temperature both are constant, and pressure is inversely proportional to volume. Okay. तो ये होता है Boyle's law. Is it clear? Boyle's law is clear. to everyone?
Yes.
Yes.
Okay, great. Yeah. Now, what's the unit of pressure? Any idea what is the unit of pressure? What's the unit of volume? I want a class to be two interactive. Okay, so what's the unit of volume?
Pascal.
Okay, great. Pressure, unit of pressure is Pascal, correct. And what's the unit of volume?
Liter cube.
Liter, not liter cube. It's a meter cube.
Cubic meter.
Meter cube.
Yeah,
Meter.
correct. Meter cube, or you can say liter. Okay. So here, suppose now I give a question. And do you have pen and copy? Do you have pen and copy with you right now?
Yes, sir.
Okay. So can you quickly do this question for me? So using that Boyle's law and tell the answer without pen and copy. Just think, you read and think, and you can give the answer quickly.
Hundred K Pascal.
Correct. Everyone got a 100K?
Yes.
Good, good. So it's straightforward that using Boyle's law we will do like a pressure. So this is clear to everyone, right? Okay. So simple 300 into 1 is equal to 3 into pressure, right? And pressure came out to be 100, right?
Yes, sir.
Good. Now there's a typo here. Charles law. There's a typo. So what is basically Charles law? Okay. So here basically it says that again it's for ideal gas. As I told, right? What the definition of ideal gas? So this is again Charles law. This will be followed. This will study now Charles law for ideal gas. Okay. So what it says that volume is directly proportional to temperature. When we will increase the temperature, volume of a gas will increase. Okay. So suppose if temperature will increase, then definitely right volume will increase. That's what Charles law says. Okay, so volume is directly proportional to temperature. This is what Charles law says. So again, if you say can we say that this, right? K is a constant. Okay, so you must be having idea, right? That if you need to remove the proportionality, we just need to multiply with K, and this proportionality will go up. Can we say like? Can we say right?
Yes, sir.
Yes, sir.
Great. So again here what it will come out to be V1 upon T1 is equal to K, and now V1 upon T1 is equal to K. So we can say that V2 upon T1 is equal to V2 V1 upon T1 is equal to V2 upon T2. Okay, so this is what it says, that V1 upon V2 is equal to T is equal to, sorry, V2 upon V1 is equal to T2 upon T1. This is what Charles law says. Okay, or we can say that V1 T2 is equal to V2 T1, right? So this Charles
Yes,
law
sir.
is clear to everyone, right?
Yes, sir.
Okay,
Yes, sir.
great. So now basically using Charles law and Boyle's law, basically in this gas equation came which is PV is equal to P1 is equal to T1 is equal to P2V2, or we can. So again here, what it says that this is a combination of both the laws, right?
Yes,
Can
sir.
we, right? This is clear, right? This is a combination of both the laws, and
Yes, sir.
this will say that P1 even is equal to upon T1 is equal to P2 upon T2. Great. So this is only a gaseous equation. Okay.
So actually you told about the ideal gases.
Mm-hmm,
So we
mm-hmm,
have just studied two laws after that. So
mm-hmm,
I have a doubt. Both the
mm-hmm.
laws are for ideal gases.
Yes, correct.
Okay, sir. Thank you, sir.
No problem. So now let's come for the Lussac law. Okay. So what it says that when any gases combine in a chemical reaction, they do in a simple ratio by volume. Okay. So what it means that, so basically in this reaction, this is reactant and this is a product, right? Idea, right? You have idea, right? What is reactant? What is product?
Yes, sir.
Yes,
Yes, sir.
Okay, great. So what it in this reaction is saying that 1 mole of hydrogen combining with 1 mole of chlorine gives 2 mole of hydrogen chloride. Okay, so here what it's saying that when any gases combine, they do in a simple ratio by volume. So what will happen is that 1 mole, what 1 mole means 1 mole occupies around 22.4 liter. Again, 1 mole occupies around 22.4 liter of chlorine. So either we can say 1 mole of hydrogen plus 1 mole of chlorine, or we can say 22.4 liter of hydrogen combined with 22.4 liter of chlorine, and give rise to 2 mole of HCl. So they do in a simple ratio by volume. So it's not like any complex law, but it's logical, right? That if 1 mole combining with 1 mole of chlorine means 22.4 liter combining with 22.4 liter of chlorine. तो अब यहाँ पे, so again as I told, 1 mole of hydrogen combined with, now we can say if 1 mole of hydrogen combining with 1 mole of chlorine give rise to 2 mole of hydrogen chloride. So we can say, right, that 1 liter of hydrogen combining with 1 liter of chlorine give rise to 2 liter of hydrogen chloride. Is
Yes,
it
sir.
clear?
Yes,
So this
sir.
is this great. So this is what Lussac law. Okay. So again, this is one question. Quickly tell the answer for this one. What is happening is methane is combining with 2 mole of chlorine give rise to CH2Cl2 plus. Is it a balanced reaction? Do you know what is balanced reaction?
Yes, sir.
Oh, so is it balanced right now? Is
yes,
it?
Yes,
Oh,
sir.
yes.
oh, good. So using Lussac law, can you quickly tell what's the answer of this? Any doubt in Lussac law? Any doubt in that Lussac law? Should I repeat that? Any doubt in that Lussac law?
No, sir.
No, right? Okay, great. So then let me know what's the answer of this question. You need to tell what the volume of HCl getting formed from this reaction in which 40 ml of methane is reacting with 2 mole of chlorine. So much of time. Looks like still confused in that Lussac law.
I'm not confused in that law, but
Uh,
I cannot solve this question.
okay.
Wait
Anyway,
a minute. Sir,
just
80
think.
centimeter cube.
Just think. Okay, take
Sir,
your time. Yeah.
80 centimeter cube.
Okay. This is an ml. So can you say an ml only? What's the answer in milliliter? What's the answer in milliliter? Your approach is correct. Can you tell an answer in milliliter?
80 milliliter.
Oh, good. So what is happening here? That as I told that what as per Gaseous law, what will happen? 1 mole of 1 mole of methane and 2 mole of this chlorine is giving 2 mole of chlorine HCl, right? So what is happening? That either you can say 1 mole, or again in liter you can say 1 liter of methane, okay, and 2 liter of chlorine. But here what is happening? 40 ml. It is so here either you can say 1 liter of methane gives 1 liter of 2 liter of HCl, right? Or else what you can say that 40 milliliter of methane gives how
80
much?
milliliter.
Correct. So 80 milliliter of HCl. So this is clear, right?
Yes, sir.
Great. So this is what Gaseous law says. Okay. So let's again one more question. Can you all do quickly this one? Take your time. It might take some time. So just think and let me know. Again, I'll give you the question. What it's saying that 200 centimeter cube of ethylene is burnt in sufficient air. By sufficient air means that it's a mixture of oxygen and some other airs. Okay, but in that only oxygen will get used. So what it's saying that 20% is oxygen and 80% is some gas which is gone unreacted. Okay, right? So here, what is forming is carbon dioxide and water and steam. Steam is water, right? So now we will need to know that how much is the unreacted air. So what it means that 20% is oxygen and 80% is unreacted air. So now you need to find out what's the amount of unreacted air. Is it clear? Question is clear
Yes, sir.
to everyone, right?
Yes.
And can you just bring me yes that will also do. So that I should know that everyone is understanding. Only I'm hearing is Arshita. You can ping me also, okay? So that I should know that yes, everybody is understanding. So I want this question for you from you guys to solve it, okay? And that how to find out unreacted air. Take your time, 2 minutes, and think and let me know.
– 2400 centimeter cube.
Okay. From everyone? Arshita, what's the answer? Riddhi?
Sir, 2400 centimeter cube. I said that.
Okay. And Shakshi?
So just a minute.
Okay, take your time. Shweta? Shweta, what's the answer? Did you try it? Are you trying?
Yes.
Okay, think and try. Same Lussac law you need to apply here. Soumya, did you try? Are you trying?
Yes, sir, just a minute.
Sure.
Sir, I might be wrong, but my
Mhm.
answer is 3000 centimeter cube.
Okay. So how you're trying? I think you're trying in a correct way, but something you're missing. Yeah, can you tell how you're trying?
So as it is given, 20% of oxygen has been used in this process.
Okay.
So I took the volume of ethanol, and then with that I took out the volume of oxygen.
Correct. So what the volume of oxygen getting used?
It is
600 centimeter cube.
Okay.
yes,
Great.
sir.
Good. Then
And then I took out like 20% of oxygen has been used. So 20% of, I assume that total gas to be X. 20% of X is 600 centimeter cube.
okay, great.
And after calculating, I got the volume of X, means total amount.
Okay. So what was it?
It was 3,000
Correct.
centimeter cube.
So in that in that 3,000, how much is oxygen, which is a reacted air?
600 centimeter cube.
And what the unreacted air?
2,200 centimeter, 2,400 centimeter cube.
Oh.
2,400.
So the answer is 2,400, right?
Okay.
Yes, sir.
Yes, sir.
So everyone is clear?
Yes, sir.
Yes, sir.
Okay, great. So I think you can see how to solve it. Okay. So what is STP? Any idea?
Standard
Standard
temperature and
temperature and
pressure.
pressure.
Temperature and pressure.
Great. Yeah. So here again the same thing that this will require 600 centimeter cube, and so so this will come out to be 24 centimeter. Okay. Great. So I think now you all are very much clear with that Gaseous law. Okay.
Yes, sir.
Great. So now what is Avogadro law? Okay. So what it says that it if the temperature and pressure remain same, equal volume of gases will have equal number of molecules. And what it means that suppose there is a 2 mole, okay, 2 mole of any gas. So now how much will be the volume for this one? As I told that 1 mole at STP, 1 mole will occupy around 22.4 liter.
22.4 liter. Yes, sir.
22.4 liter.
44.8.
Sorry, yeah, correct. So 44.8.
44.8.
Correct.
Yes, sir.
So again, it's what is saying that equal number of molecule. So this 1 mole generally, this you will study in further slides, that 1 mole contain around 6.023 into 10 to the power 23 molecule.
Yes,
1
sir.
mole of molecule. So again when temperature and pressure remain same, equal number of it remains same, equal volume of gases will contain equal number of molecules. So somehow, so if you correlate, so this is the same thing which you know that from these all things only they have created a law. So 22.4 liter will contain how many mole? 1 mole, and it will contain every time how much molecule? Avogadro number of molecules. So either it's if temperature and pressure remains same, this the equal volume of gases will contain equal number of molecule. Okay, is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now, what is atomicity?
The combining tendency of an atom.
Okay, good. So if you see here, in atomicity, basically defined as a total number of atoms that constitute a molecule. Okay, so so this you are saying that this is monatomic, right? So this will not combine with anyone. So these are the noble gases we say. Okay,
Yes.
here monatomic. This is monatomic. Again, this is a diatomic. So this is a hydrogen H2 N2. So any idea why this is H2 and N2 and O2? Why this is diatomic contain H2? Why atoms are combining?
Because they are not stable in their monatomic structure.
Yes, sir.
Correct, correct. So why only H2? Why not H3?
Sorry, sir.
It's why H2, why not H3? Why we say that it's H2, right? This
Because
diatomic, yeah.
They are stable in the by the two by the diatomic structure, and they don't further need it.
Why and okay, good,
So to complete the octet rule.
correct. So this H3 is following octet rule. Is it like that?
Yes, sir.
Okay. So here basically H and H. So these are joining, and this is forming H2. So if either 2 or 8, so these are the stable, right? So
Yes,
Yes.
sir.
either should have 2. So that's fine. This atomicity came into picture. That two hydrogen is combining and it's giving H2. So this is diatomic. Similar in the same way, this is O2, and this is O3 ozone. This is triatomic. And what is tetraatomic? It contains composed of 4 atoms.
4 atoms.
And what is optomic?
8 atoms.
8
8
atoms.
atoms.
8 atoms.
Okay, great. So generally we say that what is polyatomic, which composed of 3 or more atoms. Okay, this is generic term, but this is like for acid and P4. But this is a generic term. If it contains 3 or more, then this is called polyatomic. So it's clear, right?
Yes, sir.
Yes, sir.
Yes, sir.
Great. So now we'll go through what is homoatomic. So these are the molecules which are made of same atom. Like, can you give example of homoatomic?
Oxygen.
So
Oxygen,
H2O2.
H2, great, good, good, correct. So these are the hydrogen and can you see tell that how we are saying this atomicity is equal to molecular mass upon atomic mass?
No, sir.
Just think.
Yeah, because molecular mass is
Suppose
also the atomic weight. No? No,
so
atomic mass. Sorry.
yeah. So for O2, what is the molecular mass? Any idea? For oxygen, what is the atomic weight?
So 16.
16.
Correct. So 16 is the atomic weight, and what is the molecular mass for it?
32.
Correct. So atomicity, what the formula is coming? 32 upon 16. What it's coming?
So
16.
2.
2.
2,
2.
right? So or what the
Yes.
atomicity of oxygen?
So 2.
2. So that's how this formula got derived. Okay. This
Yes.
atomicity, we are saying that molecular mass upon atomic mass. Just think. Okay,
Yes.
it's not like just learn the definition. You should think also. Okay, think more,
Yes.
and that will be better. Great. So what is heteroatomic? What is saying that heteroatomic are made of different elements. Okay, can you tell me that in oxygen, this molecule, what is the element? What is the element?
Oxygen.
What is the element made
Oxygen.
of? Okay, so how we define element?
The pure substance which cannot be broken into 2 or more substances by any physical or chemical means.
Okay, great. So so now what it's saying that it's made of different element, right? So can you quickly give an example?
H2O.
H2.
Correct. H2 or HCl. What about HCl? Hetero or
H-
homoatomic?
Hecto.
Hetero.
Correct. So these are made of different elements. So that's why it says now. So this has 2 ammonia, methane. So these are example of heteroatomic. Okay, is it clear?
Yes, sir.
Great. So again, it can be diatomic, triatomic, right, and polyatomic. So this is again containing 3 molecules. So this will be called as triatomic, right? And So this is what heteroatomic. Okay.
Yes.
Okay. So one quick question for this one. Can you give the answer for this one? This is a reaction. Ayushi, you joined now, right?
Yes, sir.
So you have any idea about Gay-Lussac law?
Sir, can you please repeat?
Yeah. Do you have any idea about Gay-Lussac law?
No, sir.
Okay. Just can you, let me just brief it right away so that you can involve in this question. Basically, what Gay-Lussac law says that suppose there is any reaction H2 plus Cl2 give rise to 2 HCl. So what it says that 1 mole of hydrogen plus 1 mole of chlorine give rise to 2 mole of HCl, right? So what it says that 1 liter of hydrogen combining with 1 liter of chlorine gives 2 liter of HCl. Okay, hydrogen chloride. So suppose 80 suppose there is 80 ml of hydrogen, and combining with 80 ml of chlorine, how much hydrogen chloride it will form? Can you quickly tell Ayushi? 80 milliliter of hydrogen will give how much milliliter of hydrogen chloride? Can you give an answer quickly? Is it clear? Is it clear, Ayushi?
Yes.
That 1 liter combining with 1 liter give 2 liter of HCl. So 80 ml will give how much ml of HCl? Just let me write. So 1 liter will give 1 liter will give 1 liter and 2 liter of HCl. So here suppose so 80 ml will give how much? I should think unity method, right? 1 liter is giving 2 liter of HCl. So 80 ml will give how much HCl? Ayushi, can you quickly tell me that 1 liter is giving 2 liter, then 80 ml will give how much HCl?
So please wait.
160, right?
Yes, sir. 160.
Just quickly think double, right? Double of hydrogen. So 80 ml will give double of this, right? Hydrogen. So this will give 160, right? Right?
Sir. Yes, sir.
So just think, okay? Quickly think. लॉजिक जल्दी जल्दी लगाने का, ठीक है? यहाँ पे अब देखो, यहाँ पे क्वेश्चन मैंने कराया था जस्ट 40 मिलीलीटर ऑफ मीथेन हाउ मच कितना देगा 80 ml ऑफ हाइड्रोजन क्लोराइड, ठीक है? देखो यहाँ पे ये एक रिएक्शन हो रहा है तो मीथेन 40 ml है तो कितना देगा 80 ml देगा हाइड्रोजन क्लोराइड। अब हम लोग को एक मेरे ख्याल से क्वेश्चन तुम लोग ट्राई कर सकते हो, सब लोग ट्राई करेंगे। Yes, you all try this question and let me know the answer. Yeah, the reaction. What the reaction here? It's a reaction. Okay. So what it's saying that for 450 centimeter cube of nitrogen monoxide, तो यहाँ पे क्या हो रहा है 2 मोल नाइट्रोजन मोनोक्साइड का है, कितना कितना नाइट्रोजन ऑक्साइड बन रहा है 2 मोल, राइट? तो 450 सेंटीमीटर क्यूब ऑफ नाइट्रोजन मोनोक्साइड 200 सेंटीमीटर क्यूब ऑफ ऑक्सीजन गिव राइज टू 2 मोल ऑफ, तो ये कितना फाइनल मिक्सचर में क्या कितने गैस को मतलब गैस के क्या क्या कॉम्पोजिशन होंगे, लेट मी नो। ओके
So
Yeah.
Total mixture equals 450 centimeter cube.
Sorry, how
the
much?
resulting mixture will be 50 centimeter cube.
50 centimeter cube of
is the resulting mixture.
So how much nitrogen oxide will be formed? You know, how much nitrogen oxide will be formed? Aishi, can you tell or the answer for this one?
Sir, nitrogen oxide 400 centimeter cube.
Okay, okay, good. So Aishi, can you tell how much nitrogen oxide will be formed? Yeah. Ayushi, I want answer from you. Ayushi, just think Ayushi that यहाँ पे कितना 450 सेंटीमीटर क्यूब ऑफ नाइट्रोजन मोनोऑक्साइड, राइट? और तो यहाँ पे क्या होगा? यहाँ पे हो क्या रहा है? क्या पूरा का पूरा नाइट्रोजन मोनोऑक्साइड कंज्यूम हो जाएगा? Ayushi, can you tell that पूरा का पूरा नाइट्रोजन मोनोऑक्साइड कंज्यूम हो जाएगा? अगर ये 200 सेंटीमीटर क्यूब ही है तो क्या पूरा का पूरा कंज्यूम हो जाएगा?
नो सर।
नो, क्यों? ओके, सोचो कि क्यों नहीं होगा? ये 200 है तो ये कितना कंज्यूम होगा? जस्ट डबल, राइट? ये 1 मोल तो ये 2 मोल, तो ये 200 तो ये कितना कंज्यूम होगा?
400।
करेक्ट। तो 400 होगा तो कितना बच गया?
50।
करेक्ट। 50 सेंटीमीटर क्यूब नाइट्रोजन मोनोऑक्साइड बच गया। और ये कितना फॉर्म होगा?
NO2।
कितना फॉर्म होगा? कितना सेंटीमीटर क्यूब?
2
ये 200 है, ये 200 कंज्यूम हुआ, ये 400, और ये कितना होगा? What Lussac's law say that 2 mole gives 2 mole, if 2 liter give 2 liter, 30 ml will give 30 ml, 400 centimeter will give
400 centimeter.
correct. So this is 400 centimeter cube, right? And how much this is left? 50, right? So this is 50 and this is 400. So how much is the composition?
450.
450. Good, great. So is it clear to everyone?
Yes.
Yes.
Okay, good. So this is what volume of one volume of oxygen. So this is how the answer is 450. So hope it's clear to everyone. Yeah.
Yes, sir.
Okay, great. So now we'll come to mole. Okay. So mole as a basic thing I have told, right? That what it can. This is what Avogadro number. Okay. This we can't write all the zeros, right? 23 times 0. So that's why we have written it in a scientific notation form. So this is what scientific notation form. Okay. So this is what scientific notation form. So what mole contain? That mole contain Avogadro number of chemical unit. It can be atoms, molecule, ions, or others. So is the definition of mole very clear to everyone?
Yes, sir.
Yes.
Okay. So 1 mole of apple will contain how much mole? How much apple? Can you tell?
Sorry, sir.
1 mole of apple will contain how much apple? Can you tell quickly?
6.0221.
6.02214076.
Correct. So this so mole is basically it's a combination of Avogadro number of item. Okay. So it can be anything. So is it clear to everyone?
Yes, sir.
Good.
Yes.
So now what is relative atomic mass? एटॉमिक मास यू तो पढ़ लो, राइट? कि जैसे ऑक्सीजन का हमने क्या देखा? ऑक्सीजन का एटॉमिक मास कितना था?
16. Sorry.
16 तो ये बेसिकली होता क्या है ना ऑक्सीजन एटॉमिक मास इनिशियली जब किसी एटम का वेट निकालना था ना इनिशियली when we need to find atomic mass so what we think that कैसे इसको मेजर करें है ना तो जैसे सपोज अगर कोई वेइंग मशीन होता है राइट तो उसमें या सपोज अभी एक मान लो देयर so there are 3 blocks okay 3 blocks okay and this is 5 meter cube ये 5 मीटर ये मेजर किया हमने मेजर करके हमने यहाँ पे 5 मीटर कर दिया इसको हमने 10 मीटर कर दिया और ये 15 मीटर है तो अब सपोज अगर जो मेजर करने वाला स्केल है वो दैट गॉन ओके एंड अब अगर अब इसको मेजर करना पड़े दिस इज 4 टाइम ओके तो अगर मेजर करना पड़े तो इसको कैसे मेजर करोगे एनी आइडिया कैन यू गिव मी थिंक एंड लेट मी नो now we don't have any scale and
with the help of any of these blocks we can measure the larger one
correct तो यहाँ पे क्या हो रहा है कि होगा कि इसको हम लोग एक बेस बना लेंगे ठीक है और इसको हम लोग बोल देंगे एक यूनिट है ठीक है फिर यहाँ पे अब ये है ये अगर ये एक यूनिट है तो ये कितना यूनिट हो जाएगा 2 यूनिट ये कितना हो जाएगा 3 यूनिट तो ये और फिर अब यहाँ पे अगर ये देखेंगे तो ये कितना हो जाएगा ये सपोज 4 टाइम है तो कितना हो गया 4 यूनिट तो यहाँ पे भी क्या हुआ कि एक कार्बन कार्बन को कंसीडर किया कार्बन का 1/12 मास को इन्होंने एक यूनिट बना दिया ठीक है तो इसको ये लोग और इनको ये लोग बोलने लगे क्या 1 AMU ठीक है ये शायद मतलब तुम लोग बुक में डिटेल में ना हो लेकिन थोड़ा इसको ध्यान सुनना कि कैसे होगा ये कि इसको बना दिया उन्होंने एक यूनिट ठीक है तो अब क्या हुआ कि जैसे अब ऑक्सीजन का मास ऑक्सीजन का एटॉमिक मास देखते हैं जो हम 16 MU राइट तो इसके रिलेटिव में होता है ये ठीक है जो हम लोग बोलते हैं ना 16 AMU इसे राइट 16 AMU unit of atom okay AMU basically we use for measuring mass of any atom so with this 16 AMU is basically relative to this carbon C/12 right तो इसको ध्यान से सुनना ठीक है दिस इज वेरी इंपॉर्टेंट क्योंकि ये तुम्हें अभी जो पढ़ रहा हो वो 11th में भी पढ़ना है 12th में भी पढ़ना है फर्दर भी पढ़ना है ठीक है दिस इज वेरी इंपॉर्टेंट कि रिलेटिव मास क्या होता है कि एक कार्बन लिया कार्बन का कितना एटॉमिक मास होता है 12 राइट 12 पढ़ा होगा राइट
यस सर
तो 12 इन्होंने मेजर किया कि 12 यूनिट है और फिर इसको 12 से डिवाइड करके इसको बना दिया एक यूनिट 1 MU यहाँ पे क्या जैसे कि यहाँ पे क्या किया था इसको 5 से डिवाइड करके एक यूनिट बना दिया था हम लोग ने राइट यहाँ पे 10 मीटर था तो इसको यूनिट बना के हम लोग ने हमने बोला यहाँ पे 2 यूनिट यहाँ पे बोला 3 यूनिट तो यहाँ पे हमने क्या बोला कि कार्बन को 12 को डिवाइड करके यहाँ बना दिया 1 यूनिट ओके इसको बना दिया हमने 1 यूनिट और अब इसके रिलेटिव में हम लोग सबका हम लोग मास डिफाइन करने लगे okay so this is so that's why this is called relative atomic mass okay so it is a ratio of average mass per atom of element from a given simple 1/12 mass of carbon so this side is 16 MU what this is 16 into C/12 right
yes
sir
C/12 जो मास आएगा उसका 16 टाइम है This is very important. Is it clear to everyone?
yes sir
yes sir
Okay. So in other words, what we can say that it's a number of times an average atom of element is heavier than 1/12 of carbon, right? We can say that कितना time heavy है C/12 से ऐसा भी कह सकते हैं, right? इस तरह से define कर सकते हैं, right? कि how much time it's heavier than C/12. So this oxygen is how much time heavier than C by 12?
16.
So 16 times.
Okay. किसी को कोई कंफ्यूजन इसमें, क्योंकि ये बहुत इंपॉर्टेंट टॉपिक है, ये ना 11 12 में भी तुम्हें पढ़ना होगा फर्दर, और न्यूमेरिकल जो भी करोगे अगर ये क्लियर नहीं होगा तो बहुत कंफ्यूजन होता है। तो वन मोल ये, लेकिन जब 16 AMU की बात हो रही है तो ये क्या है? ये
Relative atomic
एटम है या
mass.
मॉलिक्यूल है?
Molecule.
सॉरी, दिस O इज एटम एंड
Atom.
तो यहाँ पे ये एटम की बात हो रही है, ठीक है?
Yes.
तो एटम की बात जब होती है तो 16 AMU होता है, और 16 ग्राम भी कभी-कभी देखते हो ना कि 16 ग्राम वेट है,
Yes, sir.
Yes, sir.
तो कंफ्यूजन होता है नहीं कि नहीं होता है कि 16
Of
AMU
course
बोलेंगे
होता
या
है।
16? हाँ,
Yes.
होता
होता
है।
है ना?
होता है।
ओके। तो जब भी 16 AMU की बात होती है ना, तो यहाँ पे क्या होता है? एटम की बात होती है, ठीक है? और जब भी 16 ग्राम की बात होती है तो मोल की बात होती है, ठीक है?
Yes, sir.
तो ये कीवर्ड है कि AMU की बात हो रही है तो एटम की बात हो रही है, और ग्राम की बात, जब 16 ग्राम की बात हो रही है तो मोल की बात हो रही है। 1 मोल ऑफ ऑक्सीजन एटम विल हैव 16 ग्राम। ओके, 1 मोल में कितने एटम होते हैं? क्विकली,
6.022 into 10 to the power 20.
10,
सो
23.
उतने एटम का वेट होता है 16 ग्राम, ठीक है?
Excuse me,
Yes.
sir. Can you just repeat relative atomic mass and atomic mass difference?
Gram atomic mass.
एटॉमिक मास एंड रिलेटिव एटॉमिक मास, राइट?
Yeah, the difference.
ओके। सो एटॉमिक मास बेसिकली वही मैंने स्टार्टिंग बोला कि एटॉमिक मास जो पढ़ते हो ना कि एटॉमिक मास बेसिकली एटॉमिक मास तो नहीं होता, ये रिलेटिव एटॉमिक मास होता है, ठीक है? तो जब स्टार्टिंग में 1900 में अराउंड जब स्टार्ट हुआ ना ये मतलब मास को कैलकुलेट करने का, तो फिर देन पीपल गॉट कंफ्यूज हाउ टू मेजर एटॉमिक मास। उस समय राइट नाउ वी हैव मेनी इंस्ट्रूमेंट टू मेजर, बट 1900 में कोई देयर वाज नो इंस्ट्रूमेंट। ओके, सो उस समय फिर क्या हुआ कि जैसे मैंने बताया यहाँ पे कि इसको रिलेट कैसे किया, जैसे किया वैसे यहाँ पे C/12 को हम लोग ने एक यूनिट डिफाइन कर दिया। तो बेसिकली एटॉमिक मास जो हम पढ़ते हैं वो इट्स सेम, वो रिलेटिव ही होता है कार्बन C/12 का, ठीक है? दैट्स व्हाई इट्स
Okay,
कॉल्ड
sir.
रिलेटिव एटॉमिक मास। ओके,
Yes, sir. Okay, sir. Thank you, sir.
ग्रेट, नो प्रॉब्लम। सो यहाँ पे क्या हुआ कि तो AMU की जब बात होती है तो किसकी बात होती है?
Atoms.
एटम्स,
Atoms.
एटम की, और ये 1 एटम की, और ये 16 ग्राम की बात जब बात हो रही है तो मोल की बात होती है।
Mole.
ओके, सो नाउ इट्स क्लियर राइट टू एवरीवन?
Yes, sir.
Yes. Sir.
Yes, sir.
ओके, ग्रेट। सो जैसा कि मैंने बताया यहाँ पे जैसे मैंने बताया कि इसको इन्होंने एक यूनिट बना दिया, ठीक है? और इसको यूनिट बनाया तो यहाँ पे इसको व्हाट इट सेड दैट 1 AMU इज इक्वल टू mass of carbon atom by 12. Now we can say that mass of nitrogen atom, what it is? This is the 14 time of, as I told, right? What the definition says that it's how much time it's heavier than 1/12 of carbon, right?
Yes.
So following this definition, what we can say that mass of nitrogen atom is 14 times mass of carbon atom upon 12, right? So this is now you can correlate with this one, right? Height. So
Yes,
here
sir.
so try to relate all and you will understand the logic. Okay. So this is 14 times heavier. And this oxygen is how much time heavier? 16 times.
16.
So so you say right 16 AMU. So now I think you must be clear that what 16 AMU means. 1 AMU is equal to this mass of carbon atom by 12. So this mass of oxygen atom, this is what? 16 times mass of carbon atom upon 12. So this is 16 AMU, right?
Yes, sir.
So atomic
Yes, sir.
mass is a number which tells how many times an atom is heavier than mass of. This is what definition called, right? This is what we studied, right?
Yes, sir.
Yes.
So now I think no need to learn, but just you need to understand, right?
Yes, sir.
So this is clear, right? So what is this? Can you tell? Can we say this?
The Avogadro number.
Yes, this is the Avogadro number, but how we are seeing that this is equal to this 1 by Na? This thing and tell. This is the last topic.
So please repeat.
So just I want to know that how we say that mass of carbon atom by 12 is equal to 1 by Na. This I don't think this will be in your book, but I want you to know, because it will be used in further classes. Okay, so just I want to know just how can you correlate. Think
So
that
what is
mass
this
of
Na is?
Na is Avogadro number. This is Avogadro number. Okay, number. So now just think and tell how this mass of carbon atom by 12 is equal to 1 by Na.
No idea, sir.
No idea. Okay, just think that what that mass of carbon atom is how much. So what the atomic mass of carbon 12?
12.
12. And so this is basically this mass of carbon atom is 12, and how much 1 mole of this atom will contain 12 is a mass. So this Avogadro number of atom will have 12, right? 1 mole of this 12 is a mass of 1 mole, right? This 12 is a mass of 1 mole, right? 1 mole of carbon atom, right?
Yes.
Yes, sir.
Okay, this 12 gram, sorry, I mean this 12 gram is a mass of 1 mole of carbon atom. So 1 mole contain how many atom? Na atom, right?
Yes, sir.
So 1 atom will what the weight of 1 atom? So Na atom weight 12 gram. So 1 atom will weight how much?
No, 1 by n.
1 by 12.
1 by Na.
Sorry,
1 by n.
an atom will weight 12 grams. So one atom will weight
1 by n.
1 by 12.
1 by Na.
no. Just
1
think,
by 12.
an atom weight 12 gram. So one atom will weight how much? 12 by Na, right?
12 by n. Yes, sir, sorry.
It's a unitary method, right? So 12 by Na. So if you put here the 10 by Na, so 10 and 12, sorry, 12 by Na, 12 and 12 will got cut, and what it will left 1 by Na, right?
Yes.
Yes, sir.
Yes, sir.
Okay, so that's why we say that 1 am is equal to 1 by Na.
So I didn't get this 1 by Na thing.
Okay, so 1 AMU is basically हम क्या बोलते हैं कि मास कार्बन का मास है, एटॉमिक मास है 12 AMU, right?
Yes, sir.
So sorry, 12 ग्राम. 12 ग्राम, अगर 12 ग्राम बोल रहे हैं तो क्या होगा?
Oh, mole.
Mole, right? So
Yes, sir.
1 mole contain how many atom? 1 mole contain
0.0022 into 10 to the power.
10 to the power 23.
correct. So 10 to the power 23 atom weight how much?
12 gram.
12 gram, right? So
Yes.
so one atom will weight how much?
12 by
12 by
one
n.
12 by Na, right?
12 by 1 mole.
So
Yes, sir.
so here what I'm putting just 12 by Na. This is, and this came out to be 1 by Na, and this is again same as so this we have considered as a base, and we say that this is 1 unit, because the 1 atom की बात हो रही है यहाँ पे, है ना? यहाँ पे 1 atom की बात हो रही है, right? हाँ?
Yes, sir.
राइट. तो इसीलिए हम लोग बोल रहे हैं कि 1 AMU केम आउट टू बी 1 by Na. और फिर अब हर हमेशा हम लोग क्या कर रहे हैं, इसको एक यूनिट बना के मास ऑफ नाइट्रोजन एटम जो बोलते हैं 14 टाइम, राइट. सो दिस इज द रिलेटिव मास, दिस इज अगेन रिलेटिव मास. ओके.
Yes.
Okay, sir.
ये इसको ना अभी फिर से सुनना, फिर से समझना, ठीक है. ये क्योंकि ये बहुत इंपॉर्टेंट कॉन्सेप्ट है. तो नहीं समझ आएगा तो कल फिर से हम लोग इसको डिस्कस करेंगे, ठीक है. सॉरी, कल नहीं, नेक्स्ट क्लास. कल तो मैथ्स क्लास है, नेक्स्ट क्लास हम लोग डिस्कस करेंगे. तो
Okay, sir.
ठीक है. तो अभी तक कोई डाउट किसी को? अभी जो मैंने पढ़ा है, क्या आज रिलेटिव एटॉमिक मास, जो सारे लॉज पढ़ा है,
No, sir.
डाउट किसी को? Go through this again and try to do more numericals. Okay, I think you must be having lots of numerical for
So
the
can you
topic.
please send the PDF on the group?
Sure, I will send it. Yeah. Okay. So पर ये है कि मतलब कि न्यूमेरिकल से बहुत करना, ठीक है. न्यूमेरिकल जितने करोगे उतना कॉन्सेप्ट क्लियर होंगे.
Yes.
Okay, sir.
ठीक है. तो
Yes, sir.
ओके. सो टुडे आई एम एंडिंग द क्लास. कोई किसी को प्रॉब्लम हो तो मुझे पिंग भी कर सकते हो, मुझे मैसेज करना. आई विल क्लियर इट एनी टाइम. ओके. एंड आल्सो आई एम forming the WhatsApp group for what all you are solving. You need to send in the group, okay? Because I want that everyone should solve daily, okay?
Yes.
Okay, sir.
So you need to solve the questions and send in the group, and we will see in between. We will see how you are doing, okay? And if any things you're missing, any steps you're missing, we'll let you know, okay? And again we will form a problem query group of WhatsApp. So in that you can send a query anytime, okay? And then we will try to resolve that.
Okay.
Okay, sir.
Because it's in 1 hour, suppose if you are not able to resolve all the queries, then we are there for you anytime, okay?
Yes, sir.
Okay,
Yes.
fine.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
No problem. Bye.
Bye, sir.